Hey everyone, I wanted to record another helper video on, this time on the independent versus dependent variables that we worked on in class. So let's get right to it. I'm gonna share it so you can see it from the iPad perspective here in a couple seconds. All right, and now I've loaded this document already into Notability, and I imagine many of you have as well. So I'm gonna go find it right in Notability here. And so this is the graphing, this is the graphing unit independent versus dependent variables. And this is just our first introduction to independent and dependent variables. And we talked in class, there's a great explanation video right here, written explanation that you can read. And the independent variable is the thing that the experimenter, the scientist, you, when you're conducting experiments, is the thing you change, right? So in our egg lab that we did in class, we discussed that the thing we changed was the percent concentration that the egg would be in. You might have picked 1% concentration of salt. Another student would have picked another. And so we kind of combine those. So you can change the concentration of salt that you put your egg in. And the dependent variable is the thing that we measure. It depends on the thing you changed. And in this case, the circumference, how big or small, probably if you use salt, how big your egg got, the circumference of the egg is the thing we measure. That is the dependent variable. So we went over a couple examples in class, and I will attach this into Canvas so you can remind yourself of those if you weren't able to get them in class. And I will go over the answers to some of the student practice here. If you haven't done this practice yet, you should pause this video and you should do the practice. You should think first and then compare your answer to my answer. So make sure that you've given this a try before you look at the answers and my thinking, because that's going to help you learn it a lot better. Okay, I'm going to jump right in then. So in science, we start with a question. And here, this question is, will stretching a rubber band farther affect how far it will fly? So you're going to stretching, do I stretch it to here or to here or to here, and then let it go and see how far it will fly? So in this case, the thing that we change is how far rubber band stretches. Rubber band stretches. I'll just write stretch right there. So you could say 4 centimeters, 8 centimeters, 16 centimeters, right? And at each time you let it fly. And the thing that you measure is probably the distance that it flies, how far it will fly. Distance it flies. Times flies, yes. Okay. Now, the second one here in student practice, and again, if you haven't tried this, pause my video, try it for yourself, and then come back and see how it went. So I wonder if the amount of time I spend on homework affects my grade in biology. So you could say this like, does amount of homework affect my grade? So the first part of that is states the independent variable. Does the amount of homework, that's the independent, affect my grade? So whatever's affected is the thing that we're going to measure. So independent variable here is time on homework. So you could imagine that each unit, you spend a different amount of time on biology homework, right? Maybe 1 hour a night on one unit, 2 hours a night on the next, and 3 hours a night on the final one. And you see how you did in class. So the thing that you would measure would be your grade in that unit. So the thing, your dependent, the thing that is measured is grade in biology. And of course, that's a complicated experiment, right? We're really simplifying things because you might be more interested in ecology than DNA, and that could have, or you know more about graphing already. So of course, it's a little simplified here. Okay, here's a good one. Does the amount of time I spend on my phone during the day affect how I sleep at night? And so we try to be quantitative with this. So I'm going to kind of talk this through a little. So there's some idea that the more time you spend on your phone, that the light in your eyes can affect your circadian rhythms. And there's a ton of studying on this because it's brand new to humans to be staring at these things for the amount of time that we stare at them throughout the day. So the thing that you could change if you are doing this experiment, if you're doing it on yourself, right? The thing you could change is time on phone, right? So maybe 1 week, you spend an hour per day on your phone, you know, because usually the phone has like some sort of tracker on that. So, and then maybe you say, okay, the next week I'm only going to allow myself 30 minutes, 15 minutes, and then maybe I'm going to even go crazy and go without my phone for a whole week. And you would affect how I sleep at night. So you could measure this in a number of different ways, but the thing that you're measuring is how you sleep. That's not very quantitative. So how I sleep. But there are actually these new, I don't know, maybe some of your parents have it, this thing called the Whoop that does apparently measures like your restfulness or your sleepfulness and your like restlessness at night. So you could maybe use that score, or you could maybe measure how long it takes to fall asleep. But basically something about your sleep is what you're measuring. So you're controlling, right? The independent thing, the thing that you can change is the amount of time on your phone. And then the thing that we're going to measure is how we sleep. And again, we probably want to make that quantitative with numbers. And you could think about how you'd want to do that for your experiment, but that's a little bit beyond what we're talking about here. All right, so then the next thing is what we're going to do for this egg lab, and the reason we're doing it in this egg lab is an example of it, is how do you then graph something? Usually what we do in science is we collect data and we want to put that data in a graph. And the reason we do that is so we can show our results in a really easy to see way. If you just give someone a table of a bunch of numbers, right? So it's like, you know, so it's like hours, right? On the phone, 1, 2, 3, 4, sleep. And then it's like 15, 27, 19, 48, something like that. This is a data table, and these can get really long. And us humans, we're just not really good at interpreting trends often from a data table. So we put it into a graph so that we can easily interpret the results of the experiment. And we can then ask a new question or follow-up experiment. So the question then is, when you're creating a graph, where do you put the independent and dependent variables? Well, the independent variable, the thing that you can change, always goes down here on the x-axis. Whereas the thing that you measure, the thing that's the result of the experiment, the dependent variable, always goes on the up and down, the y-axis. And you actually put a label for it. And we went over a couple in class here. And again, I'll put this, make this available. And then I'll go over a couple more here. Are hummingbirds attracted to the color red? So are hummingbirds, does the color red attract hummingbirds? Does the color of my birdhouse affect how many hummingbirds I have? So you have to do a little thinking here. So the independent variable is the color, right? And in this case, it might be red, or maybe you're just saying gray, something like that. And the thing that we're going to measure probably is either number of hummingbirds, how long they stick around. So we asked, are hummingbirds attracted? So we'd say how long they stay. So let's say you set up this experiment and you have two birdhouses, one that's red and one that's gray. So that's the thing that you can change, right? And then what you measure is time spent, right? How long? So it might be how long bird, and this is really a hummingbird spends, right? So you might say, oh, hummingbird came, start your stopwatch and then measure, okay, it left. And what you're really doing is an average of the amount of time. And what you noticed if this were the data that you would see that in this case, hummingbird spent more time near the birdhouse if it was red versus if it were gray. Some example here. Okay. Here's one here. If swimmers wear bright colored swimming suits, then sharks will attack. So what you could do, so the independent thing, the thing that you can change is the color of swimming suit. And the dependent variable, the thing that you would measure, is shark attacks. So maybe if you were conducting this study, it's probably not ethical to put people either in brightly colored swimming suits or not, and then have them jump into shark-infested waters. I don't think that's a very ethical experiment. What you could do is after the fact, see. So the thing that you're going to measure, I'll start with that, is shark attacks. And the thing that you would be looking at, the thing that could change is the color of the swimming suit. So this could be bright and not bright. And you'd have to define that, of course, right? Ahead of time, you'd have to have some scale to define bright. But then you could go back through all shark attacks in 2020 or 2019, and then ask what colored swimming suit did they wear, and see if that has an effect on if more of the shark attacks happened with people with bright swimming suit than with not bright. Then you could make the claim that bright swimming suits are correlated with more shark attacks. And that's something, correlation versus causation. We're not 100% sure that the bright swimming suits cause that. They just seem to be related to it. Okay. Here's another one. Plants grow best in white light. So really what we're asking is, does white light affect the growth of plants? So in this case, the thing that we're going to change is the color of the light. Color of light. And the next thing that the thing that we're going to measure is the plant growth. So you could just measure height of your plant, or the length of a leaf, right? Or its total mass. So this is plant growth is the thing that we're going to measure. So, you could put color of light, and maybe this one is white light. And here, maybe you put a red filter on there. So that's color of light is a thing we can change. We can adjust that in our experiment by putting a filter over the light. You can get different colored light bulbs. But the thing that we're going to then measure is the growth of the plant. And again, as you learn more in science, we have to start defining, what do we mean by the growth of a plant? Do we mean the height? We should actually this is probably not a great question, because plant grows best. Usually you don't want, like, what do you, that's not very scientific. You want to say, does the color of light affect the height that the plant grows? Because maybe different colored lights make the plant grow wider versus taller, right? We need to be a little bit more structured with the way we ask questions. Okay, but the general point is the thing that you can change goes down here on the x-axis. That is the independent variable. You can change it. It doesn't depend on anything else. And on the y-axis, the thing that you measure is the dependent variable. The growth of the plant in this case depends on, we think, on the color of the light. So we're gonna go over this in a little bit more detail tomorrow in class on the next assignment for those of you. But I hope this is a good introduction to independent and dependent variables, and that this practice was helpful. All right. Thanks everyone for your time, and I will see you next time.